All right, we can go ahead and get started. If we get some nice audio there. Okay, there we go. Awesome. So, hey, everybody, thanks for joining again. This is day 2 of the kind of practice seminar going through various design help, programming help, and then installation help. So today, we're going to be covering mostly kind of inverter sizing. Very similar to yesterday, we're going to be doing some exercises with inverter sizing, and even related to probably the most common mishap, I would say, AC coupling. So that part's going to be really important, really going to be a value add for anybody that, you know, is either looking to get into batteries now and add them to existing systems, or maybe somebody that is doing a lot of AC coupling in the field already. Huge value there, as we just see a lot of issues arise from AC coupling, and we're hoping to kind of nail those down with some sizing guidelines today and some programming stuff tomorrow. Okay, so the polling from yesterday, I know some people said that they couldn't see their screen after the poll, so I did kind of play around with it today. You can exit out. It looks like it's the entire screen, but after the poll, you can always click out of it. I'll try just to show the results and then minimize the results and see if that works a little better today. All right, let's go ahead and jump right in. Oh, and as per any of my presentations, you know, just know that if you have any questions, Q&A section is open, so just go ahead and type questions in there. I hope everyone that is on today hopefully got to join yesterday, as it is just a continuation of yesterday, so we're going to hop kind of right into everything. Okay, so yesterday we talked a lot about battery sizing. Now we're going to talk a little bit more about battery sizing as it relates to battery-based inverters. So for those that have looked over our manuals, attended other trainings, just really kind of been involved with our batteries, we even harped on it last time, that's C/2 discharge, making sure that things are properly sized to match the max continuous discharge of the 2.9 and the 3.8 for these examples. 28 amps DC for the 2.9 at 48 volts, and 37 amps DC for the 3.8 at 48 volts. We're going to use 48 volts a little easier in this case, though we will be talking a little bit about 24 volts as well. Inverter output and limitations, what does this really mean? This means that for the most part, most inverters, and this might be changing soon, but currently most inverters don't have the ability to limit the output of that inverter. So it might be able to limit the output while the grid is present, or that there's another AC source. But when the grid goes down, or if it's an off-grid system, if that inverter can do 8,000 watts, it has the potential to put out 8,000 watts. What we often see is, you know, an installer do everything correctly, put a little bit of a large inverter in place, and then see an issue later on that is out of warranty because their customer went and overloaded the system without their knowledge and used the potential of the inverter to fry the batteries. Now, this is super easy to avoid. Really, you know, the easiest way to ensure that your installs are sized properly is to follow these guidelines we're going to go over, and you'll never end up having an over discharge event. Surge is a bit different. I mentioned this yesterday, 60 amp DC at 10 minutes at either 51.2 volts for the 48 volt battery, or the same amps, 60 amps DC at 10 minutes at the 54 or 55.6 VDC for the 24 volt battery. Now again, the 48 volt makes a lot more sense for these larger projects where you might be covering some heavier loads. 24 volt makes sense for some smaller stuff, and really can add a lot when it comes to small systems. But if you're going to be covering, you know, AC and heavy surge demands, 48 volts is the way to go. I want to talk a little bit about residential use and how that ties to backup, or how that ties to the C/2 rate. C/2 is, you know, maximum discharge of let's think the total discharge of 2 hours of the entire battery's capacity. Now, as far as grid-tied backup systems go, so maybe covering a critical loads panel, it's probably pretty rare that you're going to require C/2 discharge. Most of the time, your customer is going to want more than 2 hours of backup. And really, you know, if you're sizing that way, that's typically related to something commercial, is where I see that C/2 guideline used. You know, even maybe a telecom application I heard the other day talked a lot about. Well, that's sometimes I have seen telecom sites that only do want 2 hours backup on that battery. Off grid as well. C/2 again is really not, I mean, this is more for charging. It's great. That C/2 is going to make a lot of sense for pumping as much PV in as we can in a short amount of time. But as far as discharge goes, most customers are not going to want a battery bank size to discharge in 2 hours in an off-grid situation either. Okay, so let's jump right into some examples here. All right, so in this example, I'm using 2 of the 2.9 kilowatt hour 48 volt SimpliPhi batteries. This battery has a max continuous discharge, as we mentioned in the last slide, of 28.5 amps DC. If you want to put that in kilowatts to make it a little easier, 1.45 kilowatts. That's its max continuous discharge, so discharge per an hour. The max discharge at 10 minutes is 60 amps DC, and that is at 10 minutes. And if we're looking at what voltage that would be at, typically it's about, you know, if we were using nominal voltage as we did here, 51.2, but it might be a little bit higher depending on where the battery's at. So if we were to if we're looking at this battery and deciding, you know, what's the maximum inverter size in relation to these two 2.9 batteries, we could just take the max continuous discharge. Oh, sorry there. The max continuous discharge here at 1.45 kilowatts, and you'll see why I didn't put the math out here in a second. And that's the max continuous of one battery. So if we have 2, we just multiply that times 2. Now, if it's 2 batteries, I have an even easier little shortcut here. It's just simply the kilowatt hour rating, because we're going to cut it in half and then multiply it by 2 either way. So the max continuous discharge of these 2 batteries is indeed 2.9 kilowatt hours, meaning that the inverter should be sized. You should find an inverter that has 2,900 watt hours continuous or less, so that you do not see over discharge with the battery. Okay. I know that's kind of a little bit to take in here. We're going to see how this goes with the polling question, and just to get a feel for how comfortable everyone is with inverter sizing just out of the gate, and if we need to kind of dig deeper into it. Let me just make sure I see some questions. Okay. Sorry, let me go back here. Oops. All right. So let's say we have a 6.8 kilowatt inverter. That is the model of inverter, but we know based on that model that it is a 6.8 kilowatt is the inverter's max continuous discharge. The inverter's max discharge at 10 seconds equals 12 kilowatts. So that's just its surge rating. Not super important. Don't worry about the surge rating as far as when it comes to 48 volt batteries, we don't need to incorporate the surge rating in as much because it is so high, and typically the continuous and the surge, as far as I've seen, as far as sizing these batteries, always matches up to support both. So we're just focusing on that kilowatt rating, that inverter rating, the inverter's max continuous discharge. So the battery in this case we're going to be using is 3.8 kilowatt hours at 48 volts. So that is our battery that we're looking to use. And the question is, what is the minimum battery quantity of this battery in regards to the 6.8 kilowatt inverter? I'm going to go ahead and see if I can open this poll right away. Let's take a look. Right. And we are on poll number 5. So we're going to launch the poll. And it should be on everybody's screen now if you want to go ahead and start typing in your answers to the poll. And we will go through it. We're about 1 minute into polling. I'm going to give it to 1 minute 30 seconds. All right, and we will call it right there. Okay, I'm going to go ahead and try to share the results here, and you should see it on your screen, and then we'll be able to pull down the results. So it looks like there's a bit of it's actually pretty close here. I see minimum quantity of batteries for this inverter. Looks like minimum quantity, some people are saying 3 at 37% or 28 people. 59% said 4, and nobody said 6, but there was a 4% that did say 5 batteries. So I'm going to go ahead and stop sharing, and that should move the polling off your screen. If it's still on your screen, just click out of it. It should come back to the presentation, and we will see what I came up with. So in this case, what I did is take the 3.8 kilowatt hours, that's the battery's energy, total energy capacity. Now, depth of discharge doesn't actually play a role here. We don't have to worry about depth of discharge. We're just looking at power. We're not looking about how far down we're discharging the battery, just what the continuous discharge of that battery is. So we take 6.8 and we divide it by our max continuous discharge of a single battery. So the 3.8 divided by 2 gives us 1.9 kilowatts. That's its continuous rate of the battery. That's what is discharging. So we take 6.8, which is the inverter's kilowatt continuous discharge capacity, and we divide it by 1.9. So we get 3.5. We never want to go down in these cases. Rounding down would never make sense. We always are going to want to round up to make sure that we see no over discharge. So the answer was 4 batteries. You'd be surprised how often this is wrong. I see oftentimes, a 6.8. If you're looking at 6.8 and saying that number, is very familiar. I mean, in my head, I'm using the Schneider XW Pro for this, and really thinking about, what is the. Sorry, I'm reading a little question here. Somebody's asking how to get 1.9. Again, for 1.9, we're just taking 3.8, which is the total capacity of the battery, and dividing it by 2. That gives you its C/2 rate, which is its max discharge. Now, if you didn't want to do that, if you look on the spec sheet, it actually calls out max discharge at 1.9. And it gives it an amps DC. So the spec sheet actually gives you that value. But you could always just take the total capacity of the battery or the battery bank, if we're thinking multiple batteries, and divide that by 2 to get the max continuous discharge, which is C/2. As far as the inverter's efficiency goes, I'm not going to be using it for this example. I would say it's so slight that it might make a difference sometimes, but we're talking, typically the inverter can put out basically close to what it's rated for, and most of the time they are rated for pretty accurately what they're putting out as far as even efficiency goes. Okay, I think I've got another one. Yep, one more right after this, and then I think we're going to jump into AC coupling or possibly one more polling question. Okay, so we have a 2.5 kilowatt inverter. So it's the inverter's max continuous output or discharge in this case, as we're going to call it, 2.5 kilowatts. That's the hybrid, the battery-based inverter's max continuous discharge. The battery we are using is a 2.9 kilowatt hour, 48 volt battery. So again, remember, we're looking for we're looking for first and foremost the continuous discharge allowable of the battery, and then how many batteries, what's the minimum battery quantity for that 2.5 kilowatt inverter. Again, ignore the max discharge for the time being, just really not as important in this kind of situation. We can see that it does fit because we know that the battery can handle 60 amps DC for 10 minutes, and that'll fit nicely into that. But really what I'm looking for is based on the continuous discharge, what is the minimum battery quantity for this 2.5 kilowatt inverter. I'm going to go ahead and relaunch. We're going to see polling number 6 and should show up on your screen. So we'll give it about a minute 30 again and let everybody jump in with their answers. I just want to say also, I see a question that is probably the most, I think this question really relates exactly to why people mess this up so much. This person calls out max discharge as 60 amps DC, and they're going to relate the continuous calculations based on that. That is max discharge at 10 minutes. The continuous discharge of the battery is 37. If we're looking at amps for the 3.8, 37.5. Or I'm going to give you the answer here that maybe some of you are looking for again, and this is not related to this question because we're asking for the 2.9, but 1.9. Again, there's a big difference between max discharge at 10 minutes, then think of that as a surge, versus our continuous max discharge, which is what the inverter is referring to when it says 2.5 or 6.8 in this case. I wanted to clear that up a bit because I do see a few questions asking about that 60 amps. Perfect, thank you. All right, let's see where we're at with the polls. I am going to go ahead and close it right now. Looks like most people are pretty unanimous on this one. So what is the minimum quantity of batteries for this 2.5 kilowatt inverter? The assumption being we're using our 2.9 battery at 48 volts. 94% said 2. Nobody said 6. 2% said 4, and 4% said 1. No one caught my 6 there. I was hoping somebody might pick that one. Okay, so let's take a look. So this one's super easy. Again, we're taking that 2.9, that's the kilowatt hour rating of the battery, and we're trying to figure out what the max continuous discharge of this battery is. We divide that to 2, and we get 1.45. Apologies, that's not really written out. I try to just to make it easy by just think divided by 2 every time. Or again, look at the spec sheet because it gives you that value. If you look at the 2.9 spec sheet under 48 volts, it'll tell you exactly that 1.45 will be a value that's in there as max continuous. We divide 2.5, our kilowatt rating, our continuous kilowatt rating of the inverter, divided by 1.45, our max continuous of the battery, and we get 1.72 rounded up to 2 batteries. All right, we can move on now. So now we're going to go a little bit into sizing regarding AC coupled systems. Now, just a little bit, based on AC coupled systems, this is while it's not a new thing going on by any means, AC coupling's been around for a little while, and really, you know, the mechanics behind it have too. We're starting to figure out a little bit more regarding how it relates to the battery, how it interacts with the batteries, and what could cause issues versus what we know will work. So just to kind of go through it, you know, frequency shifting is really the mechanic that I see the most, if not almost every single inverter at this point, used when it comes to AC coupling in an in a grid down situation. That's the way that we can get these grid tied inverters to basically function and output to charge the batteries and even cover loads. Now, when it comes to PV limits, and when we're thinking about AC coupling, typically I want you to think back to when we talked about charge controller sizing a little bit. And charge controllers, we can size a really large array onto a charge controller. You know, we could have a battery that can only handle a little bit of power, and our array is bigger than that, but we limit it with the charge controller. We're going to go into that on programming the third day. But when it comes to AC coupled, we have to make sure that the PV is sized to that C/2. Let me go back. So again, we said 1.45 was the C/2, the max continuous discharge of a single 2.9. I can't think of any reason you'd ever have one battery and an AC coupled situation, but let's say you did. Let's just hypothetically put that out there. Then the PV needs to match that C/2, 1.45. Why is that? It's really, we've seen in the past that things go wrong with these AC coupled systems. They're not a perfect science, and oftentimes the entire PV array will not regulate based on the programming that you do. Even if you say, you know, never put more than this amount of amps or power into the battery, it still happens. So if we just size the PV to the C/2 rate, we'll never have an overcharge event. The inverter companies will often have requirements that are very close to what the C/2 rate is. So they'll have a max PV that can be put onto an AC coupled system. And when I say inverter company, I'm talking about the hybrid inverter company related to how much PV on the grid tied side is connected. We do have our access solution and our AC coupling manuals. Look into those. If you're using our access solution, which is our all-in-one, inverter, charger, batteries, and you're going AC coupled, check out our spec sheets and check out our manual. There's a ton of good guides now to this sizing requirements. I think 3.1.1 in that manual is one of the most helpful sections where it really discusses limits of the unit when AC coupling. So let's say you do have too big of an array where you can only, maybe let's say, you can only put 6 kilowatts into the battery side of things. That's just what the battery can accept. It's what the inverter can accept. And you still have an excess of 2 kilowatts. It's not super simple depending on how your setup is. If it's microinverters, typically that's probably the easiest to get done because you can typically siphon off a portion of your AC coupled array and then take the rest of it into the main loads panel as if it was just strictly grid tied, basically dividing the system and splitting the PV up. It's also really important, we're finding more and more that the grid-tied inverter's frequency range is considered when AC coupling. If it's an older grid-tied inverter, its range is probably pretty small when it comes to that, what its actual frequency range is as far as acceptable frequency. AC coupling is the use of frequency shifting. So we need to make sure, I would always talk to the grid-tied inverter manufacturer and then talk to the battery-based inverter manufacturer and make sure those two products can indeed work together. And just understand that if it's an older system and it doesn't have that wider frequency range, it's going to be a lot harder to get it to work very smoothly. If it's a brand new inverter and the frequency range is wider, it tends to work. But just check. If you even if you just call, if you've got an old Enphase system, call Enphase and they're going to tell you right out of the gate they know how these things work. They understand even the battery side of things. They're going to tell you right away, hey, no, we know that this doesn't work very well with, pairing up with the battery-based inverter and AC coupling. So just understand your existing grid-tied compatibility. And if you have any questions, call us. Call the company, the grid-tied company, call the battery-based inverter company. All of us can help you and at least direct you into the right direction of what questions to ask and if we have knowledge of if they are compatible right out of the gate. All right, off my soapbox and on to some examples here. So in this example, we have a total grid-tied PV array size of 6 kilowatts. Our battery model that we're trying to add into this existing system is the 3.8 kilowatt hour 48 volt SimpliPhi battery. The hybrid inverter or the battery-based inverter has a PV max limit of 6 kilowatts when it's AC coupled. So that's the max PV that can go into the inverter. And the inverter size, just so you know, is also 6 kilowatts. That's the hybrid inverter size. The minimum battery quantity in this case, I would just typically take either the inverter's limit or the inverter's size, which we'll call the same thing in this case, which they typically are the same thing. If it's an 8 kilowatt inverter, they tend to have that ability, not always, but they tend to. So we just take that value, 6, and again, we're dividing it by our max continuous discharge rate of the battery. So 1.9, 3.8 divided by 2, 1.9. We get 3.1 batteries. Again, unfortunately, even though it's so close to 3, this is a situation I would typically round up. Or an even smarter idea is to look at one of our other models of batteries and see if it fits into the system a little bit better. Okay. In this case, in this example, very similar, same math, 4 batteries, but the grid-tied array in this case, let's say, was 8 kilowatts. So that means that we do have an excess of 2 kilowatts of PV. So we can only run 6 into this inverter, we know, so something needs to be done about those 2 kilowatts. Hopefully it's a micro inverter system and we can easily siphon, or if it's, here's the thing is if it's 2, let's say, solar edge inverters going into it, splitting that 8 kilowatts, 4 and 4, then it makes sense just to go 4 going to the battery and 4 going to the grid directly. 4 is probably plenty in this case to charge those 4 batteries in most situations. Okay, this will be, I think, maybe the last poll or second to last poll question of the day. And then we're going to actually jump into some wiring techniques and start diving down into installation. So in this example, we've got a total grid-tied array size of 5 kilowatts. Our battery model is 3.8 kilowatt hour, 48 volt SimpliPhi. The inverter's limit for PV input is 8 kilowatts, as well as its rating for output is 8 kilowatts as well. So we need to know what is the minimum amount of batteries. Oh, I hope no one saw that. I'm sure everyone did, but that's okay. Just, if you didn't see it, hopefully you weren't paying attention. You didn't see the answer there. But what we're wondering is what's the minimum amount of batteries put onto this system? I'm going to go ahead and launch the polls. Hopefully no one, yeah, by the looks, yeah. We'll see if everyone saw it, but if so, no worries. We'll still go through the math here. I'll give it about another minute, 15 seconds, and we'll come back. Okay, give it maybe another 20 seconds here, just so everybody knows. All right, 5 seconds left. And we'll close the polls out and show the results here. All right. So here's the results that we got from that question. Looks like we're a little split, not too much though. 27% said 3 batteries, and 73% said 5 batteries. I'm going to stop the sharing there. And again, I apologize if anyone noticed the answer before as I skipped the slide. But the really, what we used here is 2 things. The hybrid inverter's limit, but more importantly, we could have used the grid-tied array size, but we need to assume, I mentioned that the hybrid inverter has 8 kilowatts of output as well as limit to PV. So we still need to consider the max output. So regardless of if the solar array is smaller in this case, we still need to consider how much that inverter can output. So the real answer was 8 divided by the max continuous discharge of the battery being 1.9. I just want to say something. I know there's been a few questions here. You know, will this be recorded so I can go back through it? Absolutely, recording all of these. Probably sometime next week we'll be releasing the recording and the slides so you can go through these again and always email me with more questions. It's a lot to try to jumble in, and it's always going to be a bit confusing. So basically, I just saw the question come through, and it's a great question. You know, should we use, if the PV array is larger, or if the PV array is smaller than the hybrid inverter's output or limit, which one should we use? Always the larger number there in that case, the limit of the inverter, the output as well. Okay. So now we've got through lots and lots of sizing stuff over the last few days. We're going to jump into and spend about maybe 15 minutes here on wiring SimpliPhi batteries, and then we'll have some time for Q&A. All right, wiring methods when it comes to SimpliPhi batteries. Parallel connections only on our standard product. We talked a little bit about the high voltage, completely different product, completely different presentation. We're just thinking our standard 12, 24, and 48 volt for this presentation. So parallel connections only, meaning you can't take two 24 volts and make a 48 volt battery out of them. We want same length, same size cables running to a common. We're going to show you a little example of that. A few examples actually of how that is. You can see here there's a common bus, all same length, same size cables running to that. And we're going to talk about combining multiple batteries a little bit more in detail, and also a little bit about terminal bus bars and using that technique. Okay, so first and foremost, we have our lug connection. So looking at the lug connection here, this is a nice little diagram. You'd be surprised it gets wrong quite a bit. You can see the order there of the nut, the cable actually connecting, the lock washer, and the nut again. So just make sure to follow that guideline. It's a 3/8 lug or a 10 millimeter. And 13.3 foot-pounds is the torque value of that connection point. Good question. Hey, I just saw a comment that I wanted to address where they're saying, you know, we don't see an output coming out of this. This is not done yet. That's why this is just, it looks like it's just being wired up as it's going. Okay, so I mentioned parallel wiring connections, same length, same size cable running to a common connection point. Here we go. This is an example of that. So we're not jumping from post to post. We're absolutely not putting it in series. We're running parallel connections up to a common connection point, which can vary a lot on what that common connection point is. So we're gonna talk a little bit about that in detail. First kind of always go-to common connection point I would try to use is depending on if you have a smaller system. So if you're connecting to an inverter power panel, typically means you only have about 3 or maybe 4 batteries, depending on the power panel. But these power panels can be purchased with the inverter and come with all the wiring, you know, basically ready to go to make your connections. Within that, so this is a case right here is actually showing the XW Plus wiring guide or installation guide, where they're showing the Schneider PDP being wired. You can see here the batteries are actually being bused. So again, same length. If you had, let's just say it shows 4 batteries here, you'd have 4 different runs going to this bus bar here, which is the positive bus bar in the battery in the power panel, which is pretty commonly used. I like these power panels. They're really nicely made and typically have enough spots and enough rating to hold up to at least a smaller system. Same thing with negative. So this is a bit of an expanded view here showing that connection point where you can actually see the negative bus bar is a little buried down there, but you can see this positive bus bar where you would be landing each battery separately in parallel on a positive connection point. So that's, again, using the inverter's power panel for wiring these batteries. Not always an option. We might have a larger system, require a lot more connection points. That's typically where I would say jump into using a battery combiner box. You can use multiples of these too. If you've got a huge system, I think I've seen plenty of systems that use like 4 or 5 of these running and then runs coming out of those. But this is a great way to make a lot of connections in parallel for the battery and then divvy out the power from there to the inverters. As far as finding these combiners and resources you might need, you know, Midnight makes a good one. That's the one pictured here, actually. Outback also makes one, I believe. And I'm sure some other companies that won't like I didn't mention theirs make their own as well. But there's also some custom design stuff I've seen. And I know plenty of installers that like to build these out with the correct bus bar, voltage, and amperage, and insulation rating, and actually build out their own combiners when using these big systems. Another great way to wire our batteries is using bus bars that actually terminal bus bars. So these lay flat on the battery, connect to each terminal as they go along. Excuse me. This is a great way to do it. You can also just have, now you have connections coming out from where, you know, basically wherever. I hate to say wherever, but you can have a connection coming out from one end. It's always not a bad idea to have, you know, your positive and negative correctly done there as far as, you know, spacing and things like that. But really, the power is very evenly distributed when you're using these kind of bus bars. So we need to understand the DC rating a bit. I know some people are going to hound me on this example. It's really just an example. I just want to preface this of understanding the rating of the bus bar, or really of the batteries. And the bus bar, they come in certain variations. You're not going to find the exact voltage and amperage you're looking for typically. You're always going to end up going up a size just based on, you know, what's available on the market. But I've got a little example here. We have 3 batteries. They're 3.8 kilowatt hour, 48 volt SimpliPhi batteries. Again, we know that max continuous discharge, that's that C/2 rate. That's that 1.9 kilowatts that we've been using, which is 37.5 amps DC. When we're looking at an amps, we know that the voltage on the high end of things, so this is important to kind of keep in mind, 56 volt DC is really the highest we typically charge at. If you know you're going to be charging a little bit higher than that, which we only recommend sometimes, then you can assume that that's your highest voltage. But really, again, we're looking for the highest voltage that the battery should be reaching. We're always rounding this number up because voltage can fluctuate. And even if you set your absorbed voltage for 56, your bulk voltage for 56, you might see a little bit higher voltage on the charging. But again, this is how to get these minimum quantities versus what you're really going to find as far as a bus bar. So in this case, I multiplied out the amps. We're putting each of these batteries in parallel. So we're only multiplying the amps here, 37.5 times 3 to give me 112.5 amps DC, being the total ampacity as far as max continuous goes. Now, I want a full disclosure here. I'm sizing based on max continuous in this. It is, and we'll talk about this coming up in a slide or two. Sometimes your local jurisdiction might require you to base your calculations off the max surge, which might be, and if these bus bars aren't rated for more than they're actually rated for, being they don't have a surge capacity, you might need to actually rate for 60 amps DC per battery. I'm not going to try to say which one is going to happen because it changes from local jurisdiction to local jurisdiction. And we'll talk about that in a second. We also know that I said I rounded up to 60 volts DC for the minimum. And again, this is the minimum. You're probably going to end up with a bus bar that has way more voltage capacity than that and probably a lot more amps DC capacity. So just keep that in mind, but we just need to know how to get that kind of minimum number to start looking for bus bars. So let's see if everyone else can get that minimum number now. I see some hands being raised. I know sometimes people just accidentally hit that button, but if you do have a question, just type it in right into the Q&A. All right. So this question, same kind of thing. We have 8 batteries though, 3.8 kilowatt hour, 48 volts. Let's just assume we're basing our local jurisdiction was saying you can actually base off max continuous discharge for your sizing of the bus bar, our highest voltage being 56, and we're looking for that bus bar rating. This is the last question of the day. I'm gonna go ahead and open the polls here in 1 second. All right, launch the poll, and I'll give everybody a minute or two here to get that answered. All right, we'll go ahead and close the polls out here. Not too much variation there. It looks like 91% gave 300 amps DC at 60 volts DC as the minimum bus bar, the minimum voltage and current bus bar requirement. 5% did say 200 amps of DC at 60 volts, and 4% said 200 amps DC at 448 volts. To the people that did answer the second question, the number 200 amps DC at 448 volts DC. Remember, we're putting these batteries in parallel. There is no voltage that should be rising above that max voltage that was given. So, as you can guess, 300 amps DC at 600 volts DC minimum. Again, you're going to find probably quite a bit more as far as definitely voltage goes, and probably amps as far as shopping around for bus bars. But I really like terminal bus bars. I would say if you're going to do it this way, probably insulate these in between just to make sure that or at least put a case over it or something. But I really do like bus bars. They tend to work really well with these batteries, and you can put them on their side like that and just make those connections. Okay. We're not going to go very deep at all into this. I just want to again mention, size your wiring and your bus bars on your local jurisdictions. You can take some examples out of my presentation, but it's always going to be different based on who's telling you what to do and who's making the rules. Max continuous, sometimes max surge other times. So this is a super handy chart. I'll try to send this out with the presentation when this is all done. We actually have a wiring guide where I've been pulling a lot of stuff in this presentation from that goes through all this stuff, has this nice really chart here. I mean, this is a great guide that you can pull up on site, make calculations. You can look it over while you're building out systems. It goes over every part and piece of wiring, gives you tons of different ideas how to wire differently. And I can even show you a link to that tomorrow, and we can kind of pull through it. But it's a really, really helpful guide and can really save you a lot of time. So this is in there, this chart here, where we're really calling out, what's the continuous of 3 batteries, 4 batteries, what's the voltage? Well, no voltage, sorry. We're just talking about continuous amps DC, which is really the important one at the specific voltage. And just kind of gives you a quick guide. Okay. So I just want to preface, go ahead and type any other questions lingering. I see a lot of questions in the Q&A, but any questions you got now that you want to get answered today, go ahead and type those in. Tomorrow, I just want to let everybody know, is going to be really focused on programming, which is a big, probably today is the most important as far as inverter sizing goes, but tomorrow, programming, I would say, is one of the most common mishaps as well. So definitely tune in tomorrow. We're going to be talking all throughout programming charge controllers, inverters, talking about AC coupling again, how that's related to programming, and even diving into battery monitors. All right, now that I've plugged for tomorrow, let's take a look at what we have going here. Missed yesterday's webinar, recording and slides available, please and thank you. It will be very soon. Probably after the entire series is done, though. Somebody asked, what's the charging amps? I'm assuming this question came early on. What are the charging amps? Is it the same limit as C/2? Yeah, that's kind of the whole thing we talked about, AC coupling. The charging is also limited to C/2. So it's the same discharge and charge, always have the same limit. Other than when we're talking about max discharge at 10 seconds. You really don't want to, you don't want to charge for 10 minutes. You don't want to charge for 10 minutes. That's not going to do you much good. Oh, sorry there. I think I just dismissed one. Nancy, you asked, sorry, I was typing and not catching that. For the grid tied example, did you use the 6 from the inverter? Yes, that is correct. I did. But they were the same, so we could have used either or. For the off-grid systems, can the batteries take cold weather? We get sometimes negative 35 C. I have some cottages that close for the winter and leave the systems off. Talk to us specifically. Is it really 35 C within the home? And if it is, yeah, probably not. That's probably too cold. You might need to look at some heater options, which we can help direct you to. Okay, I'll also answer that question about the PV or the larger. What about the 9 kW Sunny Boy Direct inverter? How to pass that PV through it? I'm not sure I know that too much. I have to look at the inverter itself and see exactly what you're talking about. But 9 kilowatts, typically if it's one inverter that's 9 kilowatts, it's going to be a really big pain to AC couple with a single hybrid inverter. Why is it that these batteries cannot be wired in series? It's the BMS. So the battery management system is designed for either 24 or 48 or 12, depending on if you're buying the littler stuff. And that's it. If you try to wire them in series, you're gonna burn that thing up, fry the batteries. Okay, so this is what is the cable size that we should use for the 3.8 48 volt. Again, I can't tell you the exact cable size because it changes based on local jurisdiction and what they want. I will say generically 4 or 6 gauge tends to be acceptable when it comes to the 3.8 48 volt for those single runs. You might have a larger cable coming out, obviously. Like if you have a combiner box, you'd want to accumulate all of those for your output of that combiner. Do the batteries include battery management systems? Yes, they do include battery management systems and max parallel. We really don't have a max parallel. You can parallel as many of these as you want. There is definitely considerations when paralleling too many 48 volt batteries where you're just going to run into big issues with the inverter being able to scale up too. So does the bus bar need to be sized for the short circuit current? Again, I'm just going to say, I'm going to plead the fifth here a little bit and just say, it's really going to depend on the code requirement in that area. Will you give me my email? Email's right there at the bottom. Feel free to shoot me an email with any questions. Yep, so that's a good point. The bus bars pictured show cables at one end rather than positive and negative at opposite ends for equal charging. Again, it's not a huge deal when it comes to those, but I think those are all just various positive connections coming out on that picture. Is there a disconnect switch for each battery? Yeah, it's a breaker that's just put on the battery. So unless you were using a bus bar, which then, it's a little different as far as de-energizing. Okay. Thank you, Nancy. I appreciate that. Kind words. Okay, so somebody's asking, where can I find more information on AC coupling with microinverters? Yeah, you just, as far as our guides go, you'll find a little bit of information. I would just check with the hybrid inverter company you're trying to pair with, as well as which will have a great guide about how to AC couple. And then if you're looking for limits and understanding if the two are compatible, talk to both the hybrid inverter company and the grid-tied inverter company, as well as us. Never hurts. Most of our team members are pretty well versed. Can the batteries be on their side? Yeah, absolutely. So he's asking me if I could glide through the first 15 minute slides. Sorry, we're just on a tight time schedule, but they will be recorded. Can older and newer batteries be mixed? Yep, we talked about that a little bit yesterday, but yeah, three years typically is our guideline. We can add new batteries to old systems. We will be sharing the presentation. Don't the batteries have a heater strip with the battery management system? Not our standard batteries. We do have some options, I think, that are still available with a heating option. Does it basically asking, does the BMS do anything when you try to charge below the minimum threshold? It won't. It doesn't have an internal thermostat unless you buy the more specific cold temperature one. So you would you could really hurt the battery by doing that. Can you explain the difference between battery management system and battery monitoring? Why don't we hold on that? Join tomorrow. I'm going to be talking a lot about the battery monitor. Just so you know, the battery management system is just what takes care of some protection within the battery as well as cell balancing within the battery. Okay, sorry, I'm reading a little bit of a long one. Okay, cool. I'll check that out. Thank you. All right. Thank you. I appreciate that. And yes, no worries on the connection to Chris Keast for the high voltage stuff you had yesterday. All right, looks like a few people asking they're going to be sending me emails. Some thank you, always appreciate it. Okay, so this question is related to the earlier one regarding the 9000 TL, the Sunny Boy transformerless inverter, grid tied. We need guidance on AC or DC couple with probably a 4048 Schneider. First of all, don't use the 4048. I don't think that thing even AC couples. You're going to want to use the XW Pro. That's the Schneider that you would want to use for sure, and you're probably going to need 2 of them. But just shoot us an email. We can help you out there, or at least connect you with Schneider and get them to help you out. Yes, again, for the temperature, you will see some pretty bad performance below these temperatures. I've seen this question a few times. Definitely not. Can the battery be operated in parallel with lead acid batteries? No go there. Let's not do that. That's going to be a bad idea. All right. We still have a few questions, but we're right there on the time limit. I'm going to go ahead and just close the Q&A. If your question didn't get answered, I see a few questions that came privately as well. So just go ahead and shoot me an email if your question didn't get answered, and I'll be sure to get around to it. I really appreciate everyone's time today. I hope everyone can join tomorrow. Again, we're going to be diving really deep into programming, which could be really beneficial. We're not just going to be talking about how to program and common mistakes, but we're really going to be diving into how you can use variations of programming to kind of help out your customer as far as, the best use case for them, and really kind of, making sure that they get the most value out of their battery. So again, I really appreciate everyone's time, and hope to see everybody tomorrow. Thank you.